Hello dear children, good morning to you all. Today we are going to start exponents, which is in page number N79 of your book. Children, whenever we write a number raised to a power, that means the number is multiplied that many times, and this form of writing it is known as exponential form or exponents. If I say 2 to the power 3, that means 2 is multiplied to itself thrice, and the number which is multiplied is the base. The number of times it is multiplied is called as the index. So if I write 2 to the power 3, here 2 will be the base and 3 will be the index. Next thing that I want to tell you is, whenever we are taking a negative number in order to find the powers of it, so -1, suppose any negative number raised to the power of an even number. If the power is even, in that case, always the resultant or the answer to it will be an positive one. Then that means we are talking about an even power will always give a positive result. Whenever the power is negative, here the base is -1, the base is a negative number, and we have a power as odd. If the power is odd, in case of odd powers, a negative number will always give a negative number. So, a negative number with an even power will give a positive number. A negative number with an odd power will give a negative number. When we do further, you will get to know that. Let us discuss about the laws of exponents, which is given in your page number N79, N80 and N81. The first law is multiplication of powers of the same base. If the base is same, children, now you understood what is base. So whenever the base is same, what we are going to do with the powers, we are adding it if there is a multiplication sign in between. When there is a multiplication sign in between, we will add up the powers. Let us see an example. Here we have 2 to the power 3 plus 2 to the power 2. Here the base is 2, base is same. So, and there is a multiplication sign in between. So, we are going to add up the powers, that is 3 plus 2 will give me 5. The next law is division of powers of the same base. If the base is same and there is a division sign in between, base is same, division sign in between, we are going to subtract the powers. That is 2 to the power 3 divided by 2 to the power 2 will give you 2 to the power 3 minus 2. After subtracting the powers, we got it as 2 to the power 1. Third law says power of a power. That means a to the power m whole to the power n. There is a power outside the bracket. In that case, it will be a to the power m into n. The powers will be multiplied to itself. For example, 2 to the power 2, there is a 3 outside. 3 is in the power outside. So, both the powers are multiplied, 2 to the power 3 into 2, and we got the resultant as 2 to the power 6. Multiplication of powers with equal exponents. Whenever the powers are same, here you can see the base is not same. Here a to the power m into b to the power m. So we have same powers. In that case, we are going to multiply the base, and in common we are going to take it as the power. For example, children, 2 to the power 4 into 3 to the power 4 is equal to 2 into 3 whole to the power 4. So we have taken the power in common and we have multiplied the base, both the base here. Same way, a to the power m divided by b to the power m. If the power is same and there is a division sign in between, so a by b whole to the power m. Or if a by b whole to the power m is given, that means this power is multiplied with, or it is the power of both a and b. So we can write it as a to the power m upon b to the power m. Next we have is a by b whole to the power minus m. Children, if the power is negative, we are just simply going to take the reciprocal of it. That means a by b whole to the power m will give me as b by a whole to the power m. If I have a negative power, a by b whole to the power of minus m, in that case I am going to get b by a to the power of m. For example, 3 by 2 to the power minus 4. Now I have a negative power here. I'll just take the reciprocal of it, and you know that 1 upon this particular base. So 1 upon 3 by 2 to the power 4 will give me as 2 by 3 whole to the power 4. In order to make it a positive power, we are taking the reciprocal. If we have a negative power, to make it positive, we will take the reciprocal of it. Next comes how to represent in standard form. Children, whenever you are going to represent in standard form, we will place a decimal point just after one single digit, and after the digit, the number of digits left towards the right hand side. So we are starting from the right hand side and checking how many digits are left. So we'll take it as 10 to the power of that many digits. Like for example, if I have 450. So 450, if I start from the right hand side, I'll place a point over here by leaving one digit to the other side. So I got 4.5 or 4.50 if you can write. This is the same thing, 4.5 and 4.50. But now how many digits are there towards the right hand side? If I start calculating from here, 1 and 2. So therefore 10 to the power 2. Similarly, let us check another example, 832. 832, if I place a decimal point after 8 and check the number of digits, 1, 2. So there are 2 digits, so 10 to the power 2. 16432. Now after the first digit I am going to place a decimal point. So 1.6432. 1.6432. How many digits are there after the decimal point? 1, 2, 3, 4. So I have placed 10 to the power 4. 10 raised to the power the integer, which is how many digits are left after the decimal point. So with this, the laws are done, children. Please go through all the laws again. Let us start with exercise 5a. The first question says to find out the index and the base. So first question, first part is 7 to the power 3. Children, you know that this is the base which is being multiplied and the power is the index. So base is 7 and index is 3. Third bit, minus 3 to the power 7. So minus 3 to the power 7, here minus 3 will be the base and 7 will be the index. Question number 2 says to find the value of the following. 7 to the power 2. 7 to the power 2 means, children, 7 is multiplied twice. So 7 into 7, that will give you 49. In the fourth bit, minus 3 to the power 4. Children, you can see the power is even. So I said if a negative number has an even power, the resultant will be a positive number. So minus 3 to the power 4 means minus 3 is multiplied 4 times. Minus 3 into minus 3 into minus 3 into minus 3. So we got the resultant as plus 81 because it had a even power. The sixth bit, 1 by 2 to the power 4. So 1 by 2 to the power 4 means here which law are we going to use? A by b to the power m. This 4 is the power of 1 also, is the power of 2 also. So a to the power m upon b to the power m. That is 1 to the power 4 upon 2 to the power 4. So we got it as 1 is multiplied 4 times and even 2 is multiplied 4 times. So 1 upon 16 as the answer. Next question, children, 8th bit. 5 to the power 0 upon 6 to the power 2. Children, remember that any number raised to the power 0 will always give you 1. So 5 to the power 0 is 1. 1 upon 6 to the power 2, that is 6 into 6, will give you 36. So 1 upon 36. The 12th bit, minus 2.1 to the power 2. The power is even, so our resultant will be a positive number. So minus 2.1 to the power 2 means minus 2.1 is multiplied twice. So minus 2.1 into minus 2.1, the resultant will be plus 4.41. In question number 4, you have to find out and write it in the form of exponents. So 2025. 2025 children, you have to write it as product of powers of prime numbers. So that is 2025. If I am finding out the prime factors of it, starting with 3, 675, again with 3, 225, again with 3, 75, then with 3, 25. Now 25 will go with 5, 5 5s are, and again 5 1s are 5. So I got 1, 2, 3, 4. So 3 to the power 4. Then 5 to the power 2, because 2 times. So 5 to the power 2. So in order to write it in the form of exponents, we will write it 3 to the power 4 into 5 to the power 2. So you are going to find out the prime factors and do it in this way. Question number 5. Question number 5. 3 to the power 2, 3 to the power 4, 3 to the power 3. All the 3 are multiplied. You can see question number 5, fifth bit. All the 3 are multiplied and the base is same in all the 3 cases. So you know the law that whenever the base is same and there is a multiplication sign in between, we are going to add up the powers. So 3 to the power 2 plus 4 plus 3. We did it together because all the 3 bases same. So 3 plus 4 plus 3 will give you 9. That is 3 to the power 9. 3 to the power 2 plus 4 plus 3 will give you 3 to the power 9 as the answer. Next bit, 7th bit. 3 to the power 4 divided by 3 to the power 2. Children, here the base is same and we have a division sign in between. So a to the power m divided by a to the power n will give you a to the power m minus n. You know that we subtract the powers. So 3 to the power 4 divided by 3 to the power 2 will give you 3 to the power 4 minus 2, that is 3 to the power 1. The 11th bit, minus 2 to the power 8 divided by minus 2 to the power 2. Again the same thing. Base is same and there is a division sign. Do not worry about the negative sign here because minus 2 is the base. So I have taken it as minus 2 raised to the power of 8 minus 2. Why? Because there is a division sign and we are going to subtract the powers. So minus 2 to the power 6. Minus 2 to the power 6, that means children minus 1 into 2 to the power 6. Because it is an even power, so we have to write it in the form of positive exponent. That means minus 1 to the power 6 and minus 1 into 2 to the power 6 means this 6 is the power of minus 1 also and of 2 also. So minus 1 to the power 6 into 2 to the power 6. Minus 1 to the power 6 will be 1 itself because the power is positive and an even number. So if you have an even power, it will turn into positive. So minus 1 is multiplied 6 times, will give you 1 only. So 1 into 2 to the power 6, that is 2 to the power 6 itself. So we'll keep it till question number 5 and I'll let you know which questions to do. Take care children.